second. So actually, basically, I and William actually work on filters together. So I'm going to talk about the rest. Later, I'm going to talk about budget and how to improve our filter circuit and what's the troubleshooting we have. So basically, filter 4, this is the model 4, right? The bandpass frequency is from 315 Hz to 800 Hz, and this is the design. I think we did this by filter app. This is the simulation, and you can see the corner frequency is corresponding here, exactly the same as those, so which is good. And this is the real result we plot by Excel, and we actually plot one by one. So this is the result similar to the one we had before. So this is the total noise, some noise, but it's still right. And this is the oscilloscope print screen, and with some, but still right, because we tested our filters works very fine. And I don't want to repeat this. It's just a filter 5. It's higher frequency and just from 800 Hz to 2000 Hz. And this is the simulations. This is the real results. This is the print screen, followed by filter 6. And I just want to show you what we had. I don't want to repeat it. Filter 7 and going to be filter 8 here. Alright, now I'm going to talk about budget, and basically we got a whole bunch of components, and the little components we build our breadboard, and it's about, we counted, it's about 150 components consisting of resistors, capacitors, and wires, and op-amps, terminals, and collectors. Most of them we actually picked up from electrical store, which from Danny, and some of them from the workshop. And basically they are free, so it's kind of like sponsored by university. And for the PCB course, it's actually, we designed it, but it's made by Mr. Pavel Simsik. And so fundamentally it's free as well. The thing cost us, which is the hand unit, actually cost us $70. And the speaker, as we said, we made a speaker, so the components we bought is, which is the wood carpet, terminal, and some deadening materials. All this costs about $150, so the total cost is $220, but two of us actually working on it, so our budget is $500, $250 each. So it's well within budget allocated for our filter parts. All right, I'm going to talk about the problems they had before. Originally, actually, we were determining which transform we're going to use, whether by fast Fourier transform or fast Wash transform. And before we were thinking, we understood that fast Fourier transform a lot, because we learned that for 3 years. That's why we decided to use that before, to cut the sound waves into different frequencies. But later on, we realized fast Fourier transform is not that fast, and it takes too many cycles. It's hard to code, hard to calculate. Then we jumped to fast Wash transform. It's a new one. We never learned about it, but I did a lot of research about it, and we go through the library, so we realized we can use it. However, fast Wash transform got a big problem, which is it cut the sound waves into different sequence ranges, not the frequency ranges. That's why eventually we didn't use that. We just want to keep the standard analog filters and let the Arduino board take over the job, use those analog to digital converters. And the other problem is actually we pick up the parts from Danny, right? He gave us all the components in a single bag, which everything mixed up. And so it's hard for us to distinguish them. That's why we used our way to do it. We actually sort. We use the multimeter to measure all the components first and sort them out in a breadboard and write to an Excel file with the corresponding location numbers. And we plug them in orders, place all of them in the breadboard, and mark them with the reference numbers. Then later on, when we decide to build our board, we just see the reference number and pick up the components easily. So we sort that out, and hence we have this done.
Good
Save
explanation.
too much trouble.
I'm telling he's doing bad.
Alright, so
He's
next
doing
time
good,
we're going to
man.
talk about what to
Come on.
improve in the next few
English
weeks.
is not his first language.
Firstly, I'm going to say we're going to improve the design of PCB because currently our design of PCB is too small. It's too easy to make the bridges between each connections. It actually happened. We have to desoldering these to fix the problem. So later on we can make a design of big PCB board and easy for us to solder in it and save troubles. And instead of the analog filters, we are thinking of adapting digital filters, but it costs more than the normal analog digitals, and they are more complex and experience increasing latency compared to the analog filters. But digital filters can reduce the manufacturer tolerance errors from the analog filters, as William said, due to the heat. All right, basically that's it. So I'm going to pass to William, Ole.